Let's talk about something that's super common but also, kind of weird and mysterious for a lot of us. The sun sneeze.
I mean, come on. This has happened to you, right? You step outside into a super bright day. Maybe you were just in a dark movie theater. You look up and bam! Achoo! If that's you, you're not alone. And it's not just some random quirk. It's a real, actual, recognized condition.
Okay, so the official name for it is the photic sneeze reflex. And the two big words to pay attention to here are inherited and uncontrollable. This has nothing to do with being allergic to the sun. It's a reflex that's literally built into your wiring, passed down through your family. And here's the best part. Scientists, who clearly have a sense of humor, gave it probably the greatest acronym in all of medicine, ACHO syndrome. I'm not making this up.
And yes, ACHU actually stands for something. Get ready for it. Autosomal dominant compelling helio-ophthalmic outburst. Whoa! Okay, so autosomal dominant just means it's a genetic trait you only need to get from one parent to have it. Compelling means, well, you can't stop it. And helio-ophthalmic outburst is just a ridiculously fancy way of saying a sun-related eye explosion. It's a perfect acronym, even if they had to stretch a little to make it work.
And this isn't some super rare thing either. The research shows that anywhere from 18 to 35% of us have this trait. That's huge. It means that in a group of, say, 10 friends, there's a really good chance that 2 or 3 of them are sun sneezers.
All right, so to really get why bright light can trigger a sneeze, we first need to understand how a regular sneeze even works.
So a normal sneeze is basically your body's bouncer. Some irritant, dust, pollen, whatever, gets in your nose. That triggers an alarm signal that shoots up this massive nerve called the trigeminal nerve, right to the brainstem. Your brainstem is like mission control. It gets the signal and immediately launches a counterattack, a powerful coordinated blast of air designed to kick that intruder right out.
And when I say powerful, I mean it. A single sneeze can blast out up to 40,000 little droplets. So yeah, your body is not playing around. But for sun sneezers, the trigger isn't some speck of dust, it's just light.
So, how in the world does that happen? This question has actually been bugging people for centuries, and it's led to some really cool theories about the brain's wiring getting a little crossed.
Just look at this timeline. Way back in 350 BCE, Aristotle guessed that the sun's heat made your nose sweat on the inside, and that tickled you into sneezing. Fast forward a couple thousand years to Francis Bacon. He figured out that wasn't right by facing the sun with his eyes shut. No sneeze. So his theory was that the sun makes your eyes water and the tears drip down into your nose. Makes sense, but the sneeze is instant, and that would take too long. It wasn't until 1964 that a doctor named Henry Everett came up with the idea that's really stuck. It's just a mix-up of nerve signals in the brain.
So where are we today? Well, modern science has basically taken Everett's crossed wires idea and run with it.
Okay, so there are two main ideas. Think of the nerve for vision, the optic nerve, and the nerve for sneezing, the trigeminal nerve, as two highways running right next to each other. One theory, summation, suggests that a sudden flood of traffic on the vision highway, like from a bright light, spills over and causes a traffic jam on the sneeze highway right next to it. The other theory, generalization, is that the brain's control center just gets a little confused. The signal to make your pupils shrink in bright light accidentally hits the big red sneeze button right next to it.
For decades, that was our best guess, a simple glitch in the system. But here's the really exciting part. Very recently, scientists have gone way beyond just theory. They've found the actual physical sneeze button in the brain.
This is a total game changer. A study from 2021, published in the journal Cell, didn't just guess at the wiring diagram, they actually mapped it out, molecule by molecule.
This image from their research is basically the treasure map. We can now see the exact path the signal takes, from an irritant in your nose, through very specific nerves, and right to the command center in the brainstem. It's not a vague crossed wires idea anymore. It's a specific biological circuit we can actually point to. So let's walk through it. Step 1, something tickles the sensory neurons in your nose. Step 2, those neurons release a special chemical messenger called NormieEDU, or NMB for short. Step 3, that NMB messenger travels and docks onto a specific group of neurons in the brainstem, and that is the sneeze button. And finally, step 4, once that button is pushed, the signal goes out to all the muscles and you get that big achoo. And this is really the key discovery. Without that NormieEDU messenger, the sneeze just doesn't happen. In their experiments, mice that couldn't produce NMB literally could not sneeze, no matter what. So this pathway is the absolute, essential go signal. And while this research was about irritants, it gives us the exact mechanism that's probably being accidentally triggered by light in sun sneezers.
Okay, so we found the biological switch for a sneeze. But what happens when that switch gets flipped in public? Because a sneeze is no longer just a reflex. It's become a powerful social signal. And that brings us to, believe it or not, the politics of sneezing.
I mean, let's be real. We all hear a sneeze in a crowded room a little differently now, don't we? What used to get a simple bless you can now get you suspicious looks and maybe a few people taking a step back. A totally harmless sun sneeze can easily be mistaken for a sign that you're sick.
A recent survey showed this so clearly. On a scale of 1 to 5, people rated their discomfort from a nearby adult sneeze at a 4, and they strongly associated it with infection. But look at the score for the photic reflex, much lower. It just shows that our brains are now hardwired to assume the worst when we hear a sneeze.
The study also found something pretty fascinating. Our discomfort level drops quite a bit when it's a child sneezing instead of an adult. It's weird, right? We seem to see an adult sneeze as a much bigger threat, even though it's the exact same biological event.
And this quote from the research paper just nails it. Sneezing, regardless of its etiology, is socially stigmatized. This means that for the up to 35% of us with HO syndrome, our totally harmless, light-triggered reflex is now a social problem. It's a wild intersection of brain science and sociology.
So I'll leave you with this question. The next time you're out and about and you hear that, achoo, are you going to hear it differently? Will you maybe think about the crossed wires, about NormieEDU, and the possibility that it wasn't a bug but just a stray sunbeam hitting someone's eyes just right? Something to think about.